Space is a very harsh environment, so at any time we could have lost them, but that never happened.
We're now into the 24th year of a 2-year mission.
I see it as the natural conclusion to a long lifetime.
Over the years, you develop a personal relationship with these machines.
My experience of Cluster has been one of the best things about my career in space.
I've been working on Cluster since the beginning of my career. It's been a constant companion.
It is a family. It is a sense of family that you get from spending so much time with them, and also from their great passion for what they do.
And the fact that it's coming to an end, it is a bit sad to see the satellites go. They've been there so steady and so robust throughout the years, providing the data that they need to provide. But on the other hand, I'm really glad that they go on our own terms.
This is an instrument that was designed to work for 2 years, but we always build some sort of contingency into these instruments to just in case something goes wrong. And we've proved that we've actually been able to run it for 24 years, which is quite amazing.
Cluster is a heliophysics mission. Heliophysics is the study of the sun and its effects throughout the solar system, including our home world. The primary focus of this far-reaching discipline is space plasma, which is a unique state of matter that is produced when gas is heated to extreme levels and is found throughout the universe. This groundbreaking mission was designed to consist of 4 identical satellites, named Rumba, Samba, Sousa, and Tango. These spacecraft work together in harmony, flying information around Earth to provide a 3-dimensional view of our nearby Earth space environment. This approach has provided unique insights into the behavior of space plasma from our sun and how it interacts with the Earth's magnetosphere, a large bubble formed by the Earth's magnetic field. It's a perfect laboratory.
We are going to see the re-entry of one of the spacecraft of the Cluster mission. The Cluster mission is composed of 4 spacecraft that are flying together for the past 24 years. They were launched in pairs in 2000 from Baikonur during 2 launches, and they successfully gathered in space and flew together for the past quarter of a century. Today, Cluster 2, number 2 spacecraft called Sousa, will re-enter near Easter Island. And we're gonna have a very special day with a dedicated flight. So an airplane will take off from Easter Island and have instruments pointed to the re-entry of the spacecraft. And with that, we really hope to understand better how the Cluster spacecraft and satellites in general disintegrate in the atmosphere of the Earth. And the goal is really to have a zero debris policy, not leaving anything behind after such a successful mission. So for tens of years since the beginning of the space age, we had either one spacecraft, at best 2 spacecraft following each other. And we are in a 3D environment, and we have 1 point of measurement. And if you do basic physics, you realize that you need at least 4 points of measurements. Otherwise, you have some hypotheses you can never test.
The specific thing about Cluster that's different to anything that came before, and let's make a comparison to, say, weather buoys or a buoy in the ocean. If you have 1 point in the middle of the ocean, you've got 1 point in the middle of the ocean. You don't know what something's happening 4,000 kilometers away. There could be a storm and it's sunlight where this one is. This is similar to what we see in space. There are these differences in location. We also have phenomena like waves, turbulence. All of these things have structure on different scales.
These are waves that you see almost everywhere, where you have a flow or wind flowing, for instance, on the water, is forming waves. And what we've seen with cluster, we had seen that before cluster, that we had this wave. But with cluster, for the first time, we have seen that this wave, when they approach, for instance, to the shore, or when they develop along the flank of the magnetosphere, they develop as vortices. So it's very similar to the wave and a surfer. When the wave approaches to the shore, it's starting to rolling up and forming these tubes that surfer like very much. And this is exactly what we see with cluster. We could see only that it was a rolling up of the wave because of the 4 spacecraft.
We could set the size of cluster to investigate those structures, and this had never been done before. We could assume it with 1 spacecraft or 2, but with 4, it's the first time you can get an idea of the 3D structure that's going on and passing you by.
If you had another mission with 1 or 2 spacecraft, there was nothing really new. So this was really revolutionary to set this mission with 4 spacecraft in an eccentric orbit, which required more than 600 kilograms of fuel per spacecraft. So it means big spacecraft. And so that was a major mission for ESA.
Because what we look at is basically invisible, we have to visualize it using large-scale simulations. We have these, let's say, point measurements or 4-point measurements from cluster, which give us an idea of what's going on in one part of that interaction, in one part of the magnetosphere, the magnetic bubble formed by the Earth in the solar wind. But what's going on the other side? We use very high resolution, highly complicated models to simulate what the entire magnetosphere is doing by the measurements that we have from cluster and other missions. And that visualization allows us to get a better understanding of the physics behind those interactions, of what we're seeing at cluster and what the relevance is to other parts of the magnetosphere and also on the ground.
Every second of every hour of every day, the Earth withstands an invisible onslaught, a supersonic flow of space plasma particles called the solar wind, which is spewed out by our nearest star, the Sun. This solar wind impacts Earth's magnetic field at a very high velocity, creating a gigantic, dynamic teardrop-shaped cavity that we call the magnetosphere. This impact forms a shockwave upstream of the Earth, slowing those solar wind particles and creating an array of boundaries and distinct regions which envelop the Earth. These regions are made up of complex plasma connections. The patterns of these invisible plasma waves are highly complex, and they can be a few hundred meters to 100,000 kilometers through the inky blackness of space.
And this is akin to a rock in a fast-flowing river, but it's not always fast-flowing. Sometimes it's slowly flowing. And that interaction has microscopic differences and sometimes macroscopic differences. And that's the kind of thing that we investigate with a mission like Cluster.
Look to the skies during particularly violent solar winds. The impact creates geomagnetic storms that produce high-energy particles. Sometimes, when these particles come scattering towards the Earth's atmosphere, they trigger the sublime glow of the northern and southern auroras. Violent actions with transcendent results.
The most powerful solar storm in 21 years that struck Earth over the weekend.
A major solar storm is giving people around the world a chance to see a spectacular light show.
NASA briefly upgraded tonight's geomagnetic storm to extreme.
Cluster is a truly international mission, primarily European, but also facilitated by collaboration with scientists from the USA and NASA.
With the support of NASA, we could make it work. But in the end, most of the money came from Europe. And the NASA support was for once, they were a junior partner. And they were not really used to that. But it worked out very well in the end. I think it changed the way NASA was looking at the European in this field. We had one mission before in the 70s, and NASA was keeping on launching mission after mission, and we were participating in Europe as scientists. But now having a full mission that we manage, we did all the operations all done in Europe, all the science operation, managing the antenna. And that changed the way NASA colleagues were looking at us.
I think we do concentrate on the big picture. I think that's why we do the job. We all do comprehend that what we're doing is very exciting and very interesting and hopefully helpful to people. I think we definitely do remind ourselves from time to time, you know, we're not just building instruments, we're building instruments that are going into space, that are going to find out things that have never been found out before. They're going to answer questions that people have asked before and nobody's been able to answer. So yeah, I think we do. I think the reason that we work in the lab is because we are answering some of these big questions. So yeah.
I think it was a good image of ESA. US and NASA would have liked to do cluster before ESA. But they had project, but they didn't have money maybe at that time to do the full cluster. They wanted to do other projects. So the cluster project was mainly a European idea from European scientists. People had worked, scientists, on multi-spacecraft before, but 1 or 2 spacecraft. So they wanted to go further, to do with 4 spacecraft.
It was very excited to enter really a cornerstone mission of ESA. So as a young engineer, I was curious about all. It was all Europe was working together. For me, the first time international cooperation, and first with ESA on one side, later when we designed our spacecraft, then with all Europe, I was closely working together with Italy, together with the onboard computer of Laban at this time, and it was really exciting to get so many different cultures together and bring at the end one satellite out of it.
I take great pride in having been a part of Cluster. I know how much knowledge it's given to the scientific community, and I know how many scientists it has trained and been a core part of the foundation of their careers. So I feel a lot of pride in having been a part of one of the instrument teams that provides the data that makes that possible.
Cluster was at the time a pioneer mission to study the sun and how the sun affects the Earth. There was a proposal made a long time ago, I think during the 80s. Eventually that became a mission that was going to be developed for ESA. And in '96, the mission was ready to be launched, and it got to become the passengers for the very first launch of Ariane 5 rocket.
I was exuberating happiness, and we finally come to this moment, this great moment. And we saw the rocket take off, and then we're watching it, and there was sort of a flash. We didn't see all the spectacular smoke that you see in that photograph that is always shown. We just saw this flash, and I said, "Oh, that's the separation of the first stage, isn't it?" Silence.
Unfortunately, this flight didn't go according to plan, and the rocket blew up 40 seconds into the flight, and that meant all 4 satellites were lost in one go.
And then came this voice. That was a cluster mission. I don't know what I said. I think I screamed no or something like this. It was, yeah, that was yeah, never expected that. So it's always possible, of course, but you just didn't really take that into account, that it really would happen.
You're working 6 years, more or less day and night, thinking about how to get them running in space, and then suddenly they explode. So I saw a strong man who I never thought they will cry. They were crying for the cluster satellites, and of course me as well. For the scientists, it was a catastrophe. So the future was changed with one moment, 1 second.
For the cluster launch, I was in a room under the Louvre in Paris, There is a huge room where you have thousands of people. It was fully packed. Invitation from Arianespace. It was the first big new rocket from Arianespace. So Arianespace had invited many people, engineers and also politics. And I was there, one of them, watching on a big screen. And then after 40 seconds, we saw this very bad image with falling debris. And then it was a disaster. The president of France, Chirac at that time, should have come after the launch to thank everybody. And then instead, he did not come, he sent his prime minister because he did not want to show up in this very bad event then.
Well, I was in the room at the French Space Agency at CNES, and there was a massive buffet. There were hundreds of people, engineers, managers. There was tons of champagne, and the lunch started, and for 20 seconds everything went fine. So people starting to applaud, and the room became totally silent. And people starting to cry. And nobody touched any bottle of champagne in the end, which was a shame. But in the end, it was a massive catastrophe, both for scientists, but also for the launchers, because Ariane 4 was so reliable that people trusted all the technology. But because Ariane 5 was really new, in the end, yes, something went wrong. Something was not tested properly, and the launcher exploded. And I remember sitting down and saying, what am I gonna do? This is the end of my career. So yeah, it's quite funny that after 25 years, I'm talking about cluster and the end of cluster.
We work very intensively with these machines. We work day and night. We work at different strange times. Yeah, there is no real holiday or Christmas or things like this. Of course there are, but you have to give priority to your job. You tend to see these machines as part of your family. Your family has to adapt to the needs of these machines. You have to plan holidays based on what the machine needs. So you actually have a relationship which is, to a certain extent, like with a human being. And therefore, when something dramatic happens, unconsciously, you tend to really feel it as if it happened to a human being.
For us, it was a funeral. Our 4 satellites were like kids, and they were just exploded. So this was really, deeper in the heart to really lose 4 satellites, 4 babies of 6 years of our life, intensive life.
When there is an emergency with a spacecraft, you don't leave, don't go back until the emergency is solved, as if it were really an emergency which is, say, life or death type of thing. Yeah, of course, it sounds like a bit exaggerated, but you feel it like this. The perception is that.
It appeared that people tried to vanish everything in one go, which could remind people about cluster. I'll give you one example. Being the flight director, but part of the flight control team, we had our flight operations plan, paperwork in front of us laying there in the main control room. And all of a sudden, you had seen that people were removing all these documents. And just to swap it away and to make this not happen. Secondly, at that time, our Director General stated, we are all guilty, which I didn't want to subscribe to because we didn't do something wrong, which was also the result of an inquiry report later on. It was just a stupidity, a mistake that Ariane 4 software was used for Ariane 5, and this was the reason, the proven reason why the mission failed. And for me, it was a very difficult time because it was the first project here in ESOC I invested, counted back from 87 January to June 96. Yeah? So it was almost a decade, and this was a bad time, but it made us stronger because I was responsible also at that time for the team here, directly responsible. People were also responsible because they had contractual relationships or so whatever. And for me, it was then important that I could ensure that everybody who worked on cluster had a future.
I was not part of the team of recovering the cluster debris in the jungle. I got those pictures from our PA guy, Arjen Timon. He was there from industry, so taking care that all the right pieces were collected, and some of the ESA staff who were there supporting the launch operations in Kourou. So I was at this time in Darmstadt, and he was in Kourou, and with the Legionnaires. This must have been a really great experience, being an adventure to go in the jungle and rescue all the pieces. So on the one hand, it's like a rescue, a little bit of getting hands on our clusters. But on the other hand, it was maybe painful, and seeing this was a tank and now it's just rubbish. This was a central cylinder and now it's just blown up, and so all the boxes inside.
This is what remained from one of the experiments on Cluster 1. We have on each spacecraft, we have an electric antenna. And you can see it here. This is this thin wire. This is actually 50 meters long. So in space, it's deployed very slowly. And as the spacecraft is spinning, well, if you deploy correctly, then in the end, you will have a fixed antenna over 50 meters, and we have 4 of them on each spacecraft. And it's quite amazing that after the explosion of a launcher, it's really in a pretty good shape, right? So yeah, those are really rock solid experiments. That's really rocket science.
When they built them, they built actually 5 models, 4 to put inside the rocket and fly, and 1 extra engineering model to have on ground for tests. And since they had that equipment already, they decided we're going to build 3 more, make again the constellation complete, and launched it 1 more time. So within 4 years, they've rebuilt, and they refurbished a little bit the engineering model, to make it flight worthy, and then they added on these 3 additional satellites.
I think to see then how our director of science at that time, Roger Bonnet, fought together with his team to get a cluster reinstated, this was fantastic. And then back in 2000 exactly, we had these two launches with the Russians, and to see also how the Russians approached the whole lot was something new to us, to me.
One of the things they did was they replaced the tape recorder, it was on the original constellation, by a solid-state memory, which means the satellites would become more robust to mechanical problems that normally occur if you have a tape recorder, which was normal back in the 90s. So they got the first solid-state recorder on board, and then they got launched 2 by 2 with 2 Soyuz rockets in the summer of 2000.
This was definitely something which also is as far as I know, unprecedented. It was exactly just 3 years to rebuild it. 3 years to rebuild it because the approval came when was it? 1997 in January, and we flew in basically 3.5 years later.
I like to think that space is still one of the areas where we continue to cooperate internationally with everybody. The impression that we have that the world is polarized in a way, and that cooperation in many areas is not possible, is a bit of a fallacy, because our life carries on and we continue to trade with everybody in the world, even if we believe in when we hear in the news that we are not talking to this one and not talking to that one. I still think the world carries on as a globalized village, and without international cooperation and without people contributing, big projects are not possible.
The beauty of everybody coming together from different countries is because it's completely apolitical. You know, we're working together on the science. There's no politics involved at all. But there is culture, so you can go to a different country, you can learn about a different country. You learn so much more about a country by working in it with the people that live there. So from that point of view, I think working with people all over the world has been fascinating, really interesting.
The missions that are the most successful and that last the longest have teams, international teams, that can work together for many, many years. And that takes trust, and it takes a lot of communication, a lot of dialogue. These are not things that I think people typically associate with science and with scientists, but it is a big part of what we do, and it is a big part of what makes us successful in answering those big, complicated questions about how everything works.
I think I came in halfway through cluster, if you count the first launch and the second launch. So I was lucky enough to do a PhD just before the second launch. And at the time I didn't know it, but it was to become a major part of my career in space.
There are many challenges facing cluster, not least describing the measurements being made. There are no cameras as such, no one image to qualify your findings. Instead of the camera eye, we capture the intangible of electromagnetic fields and plasma particles. These instruments measure the undulations and variations in the space that cluster is flying through. Think of a string quartet picking up on the melodies and tempo of the ambient plasma, these delicate instruments gathering the music of the universe as scientific data, letting us see things in a new and revolutionary way. This is the long road, decades in the making. Data collated from cluster, but also previous space missions, and data gathered back on Earth, as well as large-scale simulations and models that help us understand what the magnetosphere is doing, like unraveling a Gordian knot of complex space plasma physics equations and theories in order that we might shed light on the long-term trends of solar activity on the magnetosphere. In layman's terms, this means that we can trace an electric current observed at cluster to the aurora and back down to the Earth, literally from heaven to Earth. Cluster literally changed the way we saw space and the planet we call home. Its research into space plasma and how we see it helps set the template for a new generation of missions and exploration. For now, the magic number is no longer 4, but multiple craft, at least 7 in number, covering multiple scales at the same time, opening our eyes even wider. Thanks to cluster, we can now do more than just imagine plasma observatories and newer, evolving ways to explore and research. Thanks to cluster, the future is now.
They're still using data back from the beginning of the mission to make models and study phenomena. So, as it was originally planned only for 5 years, we would have only just seen a brief period of the life of the sun and its activity. But as it's lasted for 24, we've actually covered 2 full sun cycles with a lot of activity, low activity, lot of activity, low activity. And this is a great data set. This is an amazing data set covering so much activity, so many different conditions in so many regions around. Our orbit has not been fixed in space. It has been wobbling and moving. Our inclination has changed. We've visited many regions in the front of the magnetic field, in the tail, in the sides, on the cusps. We've been all over the place collecting an immense amount of data. Throughout the years, we've optimized the amount of data we've collected. We've collected more and more and more. We just recently, a few weeks ago, we've beaten our record for data collected within one planning period. That's a week of planning. We reached our highest value ever just recently. So that has been also always on a positive trend. So it will leave an enormous legacy for the future.
Cluster is going to re-enter near the Easter Island. According with the last result, it should be a little bit west of the island itself, but in a completely safe re-entry arc. So we are not expecting to have any issue with this re-entry. The fragment will have all under the ocean, and is everything pretty much aligned, which was the re-entry strategy that we designed since the beginning of the year. The monitor of the re-entry of clustering is very important for a scientific point of view because it's a rare occasion to observe an object as re-entering. We have the precise location of the re-entry. That is something that doesn't happen very often and is due to the particular type of orbit that is clustered on. And we will be able to observe an upper velocity re-entry and to validate model that we don't know how to modelize, so how these objects break up in the atmosphere, how much temperature it can reach, and it will give us also information on how big and where this object can survive.
You become so close to the instruments and knowing how they react under certain circumstances and caring for them and looking out after them just like family. And so this re-entry event for Spacecraft 2 seemed like a very sad event. To me, it is sad, but you know, I think about it as welcoming home a family member.
My emotions here are very divided. I'm super relieved on the fact that everything is going very well and has been so much work and so many people, so much effort, but at the same time is ending a great experience. So it's kind of finishing on both sides, sadness and happiness. But anyway, definitely awesome experience and positive feeling.
12 minutes left with visibility from our ground station in Kourou. So we were still able to see the satellite. We just had a little ceremony back there. We sent the last commands to the satellites. So we put together a special instruction for the controller, and in that instruction we just asked 10 commands to be put on the stack, and each of one of us has sent it as a way to say goodbye. It's just a dummy command to ask the satellite, are you alive? And the satellite replies, yes, I'm alive. So we asked it 10 times and it said 10 times. But if we try this tomorrow, it won't be the case. So there is half an hour left in the lifetime of the satellites.
I actually had a lot of trepidation about coming here. I almost bailed a couple of times because I didn't know if I could handle the feeling of it. Having been through the end of mission for Cassini, I remember what that felt like, and it does change. Well, it did for me anyway. It changed my kind of emotional state and my viewpoint on working on the mission quite a bit.
We are already starting to see the satellite warming up, so it's getting closer to the Earth. The radiation of the Earth is already making here the temperatures go up a little bit. Yeah, we're flying over Brazil right now, and yeah, we're approaching it any minute now.
It's a real pleasure to join you today. I'm sorry I can't be there in person, but I first of all wanted to just thank all of the teams for making the event at ESAC possible. And I know that you will have a very pleasant afternoon together here, remembering and celebrating this incredible mission. What an amazing and immense journey that this mission has had. And I think it also exemplifies the importance of long-term commitment to space science missions and all of the communities who come together, actually over generations, to make these kinds of missions possible. The cluster re-entry is planned this evening, And the uncertainty is now shrinking, which is fantastic. We will know even more how accurate that is. And the Airborne Experiment Observation Campaign is being organised to follow the breakup of the spacecraft during its re-entry. Each window of the plane will have cameras and spectrographs peeking out of them. All in all, over 20 scientific instruments will be looking for the explosion, tracking the fragments, and recording as much detail as possible. This is the beginning of a new future. Cluster lays an incredible foundation and sets a very, very high standard for future missions.
I was not looking forward to this. I've had this experience before with Rosetta, and to be very brutally honest, Cluster I feel a much greater connection to, because it was there at the beginning of my career. I built my career on Cluster. Because of Cluster, I'm here. I worked on Cluster as a project scientist for a long time as well. So this weekend's been very difficult for me, and I don't think it's yet sunk in what's happened.
As I was watching the descent, I was thinking about the fact that I worked on this for 24 years of operations. And I was trying to think about what had gone on in my life all that time. So, I've had children, they're now 17, they've gone all the way through their schooling. We've had cancer in the family, we've had lots of holidays where I've worked on the cluster. So cluster has been the one constant thing in our lives, in a lot of our lives, I think, where everything else has changed, but we've been able to rely on this instrument. So we do, from that sense, we do definitely develop an attachment.
It's a bit like family members disappearing that were the kind of coagulation. I think most people you will have family parties, and they usually are attached to old relatives. And when those old relatives pass on, the family kind of disperses a little bit. And I think there was a feeling of that this weekend. It's a bit like a family member had gone, and what is the impact of on us as the family in the future? I think we'll carry on because we still have work to do, but there's a fundamental inherent feel of family within the cluster community.
When you work on a mission for so long, it really does become something where you become emotional about a lot of things, and it consumes your whole life, especially something like Cluster, where there's 4 spacecraft in it, and everything is ×4 trying to do anything, because you get 4 instruments. And so that was new, and that was quite tiring initially, but in the end now, you always speak of these things as like they're your family.
3, 2, 1, Sousa!
When we work with these spacecraft for so long, we get an intimate relationship with them. There's not just a bunch of metal and electronics which make queer signals and such. They are our children, our family. And therefore, the other day when I started to think, what is Cluster 2 Sousa going through now? And what would Sousa say or think if Sousa could say or think? Well, I'm doing the saying and thinking for her. And this is what I came up with as a fantasy, but I think I like it. This September 2024, 11/22, apogee 3,833 at altitude 131,000 kilometers. It is cold and lonely out here in space, but I'm used to it. You can see the stars brilliantly with their intricate constellations, and the Milky Way is magnificent. Then there's the sun and the moon. The moon is currently just past new as a growing crescent. The sun is always there, but sometimes it disappears behind the moon or the earth. When that happens, I suffer a blackout. And I know nothing until it appears again. And then all my circuits start humming once more, and my passengers start doing their things. Whatever that is, that doesn't concern me. I am Sousa, one of the 4 dancing clusters circling the Earth. I have not talked to my sisters rumba, samba, and tango for years, not since we started this adventure long ago. Ah yes, the Earth. It is the biggest thing to see here. At the moment, it is 6 times larger than the Sun, but it's also a crescent right now, as seen from here. I see mainly the night side with its fascinating sparkling lights. I wonder what they are. The main attraction for me, though, is the roller coaster. It's about to start once more, slowly at first, but gradually gaining speed until it becomes a mighty rush towards the Earth, which then gets larger and larger. That is when I might glimpse my sisters as we careen around the planet, but we are moving too fast to wave hello. Yes, as we swing by the Earth, it is very large, about 5 times the size that it is seen from way out here. Usually. But recently, it's been getting much larger, filling almost half the whole sky. Oh, I feel I'm starting the roller coaster ride once more, ready for my 27-hour plunge to the Earth. I wonder how big it will be on this run. It's a shame there are no loopings. I've been doing some thinking during this ascent. It all seems so different from what happened before. Those tech fellows in Darmstadt, they know what they're doing, don't they? They usually take good care of me, nudging me a bit here and there to keep things running right. I'm going to have to talk with them the next time we have contact. I've had enough of this business. After 24 years, a lady in my age deserves better treatment. How about sending me off to Alpha Centauri for a rest? I'll be in coma most of the times once the sun is too weak to keep me awake, but that's all right. Maybe I should have a temper tantrum or do one of my switchovers to annoy them. Which one would be the best? Of course, I could try to talk to them. Normally, it is the passengers who do all the talking. You would think they own the shop. They've been abnormally quiet for some time now, so I will have all the bandwidth to myself to give Darmstadt a piece of my mind. Funny, do the passengers know something that I don't? I've reached the high point now and feel the crossover to the descent. I wonder if my sisters are going through this too. In spite of what I just said, it is indeed very exciting. It's a shame there are no loopings. 8th of December, 1848, re-entry, altitude 0. And then there were 3.
Distant Earthrise long ago lingers at the borders of our minds. Mysteries spinning in the dark, in the frozen emptiness of time. We were lost and we never knew who we were, what we left behind. Living half-lives, we were blind to the new frontiers that opened up our eyes. To find our minds were spinning, souls entwined in a spiral dance. The ancient ways that found us again to give us one last chance. Living in this place, staring into space, we find we might share the corners of our lives. Infinity runs deep, eternity that we can keep, melting through the frozen wastes of time. So we go and return to navigate the seas of the sun. Our children will go on and on to navigate the seas of the sun. So we go and will not return. We'll navigate the seas of the sun. Our children will go on and on to navigate the seas of the sun. We can go on tomorrow, living death by gravity. Couldn't stand it anymore. We sail our ships to distant shores. Purple, gold, and blue, living colors.